Good afternoon. So I have the pleasure today to introduce actually two of my fellow Brickster colleagues who are both German speaking. I'm German speaking as well, so that's a pleasure for me. I would want to introduce to you Stefania, who is a senior product manager at Databricks, mostly focusing on Databricks runtimes. But also introduce to you Martin Grund, who is a senior staff software engineer and also team lead at Databricks, focusing on the intersection of query processing, governance, and security. As you heard this morning, Databricks SQL is the easy way to actually get access to the Lakehouse architecture with a 12 times better cost performance than traditional cloud warehouses. And Databricks SQL also gives analysts the possibility to use standard SQL in order to actually query the data and transform the data. While SQL has some limitations, so therefore, sometimes it would really be nice to actually have a full program language available in order to do more sophisticated things. And that's effectively the talk of Stefania and Martin today to introduce Python user-defined functions for Databricks SQL. So the stage is yours.
Thanks a lot. Hi, everyone. We're really excited to be here. As we said, so we'll be talking about bringing the power of Python to Databricks SQL. Before we start, a quick overview of what we're going to talk about. We'll start with a short introduction about data warehousing on the Lakehouse, introducing Databricks SQL and Unity Catalog and why this is important in the context of this talk. And then we'll be talking about extensibility in Databricks and Databricks SQL today. What kind of user-defined functions do we have and what is missing? And then Martin will talk you through Python UDFs in DBSQL, and we'll also do a demo. Yeah, as you heard this morning in the keynote, the Lakehouse is the best data warehouse as it combines both worlds, like the benefits of both worlds, of the data warehouses and the data lakes. So you get to do data analytics and AI in one place with a great price performance and with a single truth of all of your data. And the data is also based on open formats. So warehousing in Databricks is powered by Databricks SQL. And Databricks SQL is our serverless data warehouse that lets you run all your SQL and BI applications at scale. It comes with a centralized governance layer, the Unity Catalog, that offers a unified governance model across your Lakehouse. Databricks SQL and Unity Catalog are seamlessly integrated, and you can govern all of your data using standard SQL grant and revoke statements. With the Data Explorer, you can easily search, discover, and access data from the Data Explorer. Plus, you get many other great features, which we also have seen this morning, such as delta sharing, where you can share data across organizations, as well as built-in lineage across tables, columns, notebook, workflows, and dashboards. So why is all of this relevant in the context of this talk? So in Databricks SQL and with Unity Catalog, you want all of your data assets to be part of a catalog. This includes data assets such as schemas, tables, and views. But there's also business logic. And the business logic is basically how you extend Databricks or Spark with what is relevant to your specific business. I mean, you typically do that with user-defined functions. And those should also be governed alongside your data assets. So let's have a look at what you can do today in Databricks with regard to user-defined functions. So user-defined functions are used to extend Spark with your very own business logic. You can define your own business logic and then reuse it across the application. For example, if you need to redact some PII data in a very specific way, that's very specific to what you are doing. And Spark doesn't have this functionality yet. Hence, what you can do is create a user-defined function, and in this specific example where you want to redact some data, you define the logic on how to redact the data. You can define this UDF once, and then it can be reused across data frames and in SQL. So let's have a look at this example here. What you see here is a Python function, redact JSON, that takes a string as an input value, and it essentially replaces all the values that have a key, either email or phone, and returns a string. So basically, after running that function on your string, there's no more PII data in the string. In order to make this Python function available on your data frame, what you do is you annotate the Python function with the @UDF annotation, and once you have done that, you can then use it on your data frame. So here we have a data frame on which we do a select on a column JSON dump, where we apply the redact function. And the resulting data frame doesn't have any PII data anymore. So this is very simple and easy. Spark offers much more, right? We have seen a Python UDF, but you can essentially define user-defined functions in the language of your choice. For PySpark, you can do Python UDFs, as we've seen, but also Pandas UDFs, or use the Pandas API on Spark directly. If you're a Scalar user or a Java user, you can define Scalar UDFs. And if you're a SQL user, you can use built-in functions and Lambda functions. Databricks SQL offers SQL UDFs. And what is very powerful is that from Spark SQL, you can actually use registered UDFs in your SQL code. We'll see in a minute how that works. So let's have a closer look, same example as before, but what are the characteristics of these Python UDFs? Again, here what we have is the redact example from before, but really what you can do is you can define arbitrary code in your Python function, whatever your business logic is. It can also be nested functions, and in order to make it available in PySpark, you use the annotation with the @UDF. If you want to make this available in Spark, in Spark SQL, you register the UDF with the Spark session. So what you do there is you call spark.udf.register, you give the UDF a name. In this example, we call it redact, and then you point to your Python function, redact JSON. So what that does is basically registering the UDF and make it available so that you can use it from within Spark SQL. In both cases, if you're like annotating it with the @UDF, or also if you're registering it for Spark SQL, the UDFs are session-based. They're not cataloged objects. So you need to register that every time you run the application. And also if you want to reuse the code across applications, you need to make sure that the code is somewhere in the vicinity, be it on the cluster or directly in your notebook. So once you have done all of that, you can use the UDF in your SQL. So here what we do is like we select the column JSON dump, we apply the redact function, and as a result, we'll get PII-free data. What is important to note here is that the UDF is processed in a row at a time manner. So for each row, we run the UDF once. What we also offer in Spark are Pandas UDFs. So here again, in this example, we have our redact Python function. Again, you can define arbitrary code. But then what is different with Pandas UDFs is that they take a Pandas series as an input value and they return a Pandas series. So basically, they don't operate on single rows, but they're vectorized. So they process batches of data. So in this example, we create this new function, redact JSON panda, which essentially takes a panda series and returns one. And what we do is that on this batch, we apply the redact JSON function. So how this is processed is that the function is called once for the whole batch, and this is faster in most cases, especially if you have a lot of row-independent state. So for example, if you have something like a model that is only loaded once, but you process it on many rows, it's much faster. We'll see that later on. Again, in order to make this available from within Spark SQL, you register the UDF with the Spark session. Pandas UDFs are session-based as well. They're not cataloged. And then from SQL, you can use them in the very same manner. The difference really being that they're vectorized and executed on batches of data. So let's have a look at what we have in terms of extensibility in Databricks SQL. What we do support today is support for SQL built-in and Lambda functions, SQL UDFs, but there's no support to call non-SQL UDFs as we've seen in the example before, what you can do in Spark. We first go into SQL UDF example. So here we have a different example as before, an email masking function. So with SQL UDFs, what you can do is basically define a reusable SQL expression as a function. In this example, it's functionality to mask emails. And by creating a SQL function, the SQL UDFs is cataloged. So we run a create function statement and define the signature of the function. We define the return value. Here is a string. We define the language is SQL. And then in the function body, or like the return statement, is your SQL expression that implements the business logic. So in this email masking example, what we basically do is that we mask the email addresses, the names, and the domains, so that everything between the first two and the last two characters is actually masked. So since SQL UDFs are cataloged objects, in order to create them, you need to have the right permission. So here we have like the user in green that runs this create statement. And that user has usage and create permission on the schema and usage permission on the catalog. In order to make this UDF available to other users after having created it, the green user needs to grant permission to their analyst users. So in this example, what we do is we grant execute on the UDF to the final analyst team. And then the finance analyst team can use that UDF in their SQL expression. So what we have here in the example is a finance analyst in yellow that runs a select query that masks email addresses so that no PII data is exposed. So SQL UDFs are really powerful, but sometimes they're also a bit limiting. They're not as expressive as other programming languages. So what you see here on the slide is basically the redact logic, once in Python, once in SQL, is a bit longer. It's more cumbersome to read. That's why we didn't use it as example in the SQL UDF. So there's some logic that is really hard or impossible to express in SQL. A second point is that a lot of the business logic, there's a lot of business logic that has already been implemented, basically by all of you that use Spark or Databricks. And it would be really nice if you could simply reuse all of that business logic in Databricks SQL. And that's really what we want to do today. We want to bring the power of Python and also all of your existing business logic to Databricks SQL as a fully cataloged and governed UDF. And I'll give over to Martin, who will show you how we do that.
All right, thanks a lot. Right, cool. Yeah, so I'm going to walk you through how we are going to allow you to use Python UDFs directly in Databricks SQL. All right, so how to get started? So fundamentally, what we're giving you the possibility is to write Scalar Python UDFs in Databricks SQL. So I really have to stress the first part here, it's about Scalar functions. This is the first step for us to say, all right, what kind of functionality do you want to bring? And Scalar functions is really very easy to use, and that's why we're focusing on them. The other part is that these functions, these Python functions that we're giving you the ability to create are first-class objects in the Unity catalog, which means they're granted and they're revoked, they're used in the same way as any other metadata object in the catalog itself, which is really important because imagine like if you pause your Databricks SQL cluster and you start your Databricks SQL cluster again, you don't have to deal with init scripts or like, where did I have my notebook that had this UDF register that this guy was using that is an intern, but then he left, then he came back. Like, you know, all of this is cumbersome, and you know, this is why we have catalogs. This is why Unity catalog exists. And the Python UDFs for Databricks SQL really leverage this to make sure that all of these functions are cataloged and managed in the right way. And lastly, the UDFs run in a fully sandbox and isolated way. everybody that has ever worked with PySpark and Spark in general knows that the integration of Python UDFs in Spark and the way the daemons work, all of this can be quite interesting because the execution of the processes is not really as isolated as it could be, which means that especially when we're talking about Unity Catalog and governance, the security primitives that we're providing have to be guaranteed across all of the product. So we're making sure that the UDFs that are executed are completely isolated and sandboxed from each other. And for example, we don't allow network access. Yes, this might be a hindrance for some, and I will talk about this a little bit in the end. But fundamentally, we want that UDFs are really this kind of stateless transformation logic expression that can be run safely without you worrying about like who has access to some temp data that somebody wrote to disk or some environment variables. Like all of this is completely taken care of. All right, so I will walk you now through like a very simple mapping example, and like I will give you a quick idea like why this is important, because the way how we define the Python UDFs in Databricks SQL works the following way. So on the left side, we have a simple Python function that has completely no meaning whatsoever. This is really just to use an example. On the right-hand side, we have the translation of this particular function already in SQL. And I will now walk you step by step through how you can map this logically. So where in Python, you basically write def, like the beginning of the function definition. This is the create function part in your SQL statement. The next thing is the function name. So yes, I translate my function name. I put it in SQL. Yes, I can reason about that. Now it's my arguments. In Python, well, everybody loves Python 3 typing, except me. But in SQL, you actually have to provide types. So you have to be a little bit more explicit there. And lastly, the function body. And that's the interesting piece here. When we basically interpret the Python function that you're defining in Databricks SQL, we're basically generating a wrapper around it that makes it a function. So the body is really what you would literally copy and paste from your existing Python function from the left side over to the right, and then you have to return something from it. So it's really a function. And if you've ever dealt with Redshift Python functions, you might have seen this before. And the syntax in general looks a little bit Postgres-y. So the $$ escape syntax, I mean, this is relatively straightforward. So this is just to give you an idea how you map logically the individual components of a Python function to the necessary Databricks SQL dialect. All right. So again, this is how the actual function definition would look like for the example that we've been using over the previous slides. We really want to drive home that fundamentally, the code that you're seeing on this slide looks exactly the same as you would write it in your Python notebook, except that now you decorate it with a little bit of SQL left and right. And all of a sudden, you can use it across all of your Databricks SQL clusters, serverless, and it becomes really, it scales. Like you don't have to worry about how to govern it. It's just there. Well, all right, awesome. So I will now basically go a little bit through how you can transition your existing business logic. Like just again, to walk you through the examples of like how you take existing code that you have in different shapes and forms and apply to basically bring it from Spark to Python UDFs and Databricks SQL. All right, sorry for that. Again, so in Stefania's examples before, we had this case where you call Spark UDF register of a function and you give it a name. Again, this maps to the top and the bottom part of the SQL string here. So create function redact. So we give this name that is registered in the catalog, and we define the return types here. And we have to always say that's language Python because we already have language SQL. Next part is you literally just copy and paste over your code. And there's one important thing here to keep in mind is that if you might have multiple functions, if you have dependencies, this is a little bit different to the way that PySpark UDFs work. PySpark uses the magic of Cloud Pickle and Pickle in general to serialize function definitions. So what happens is that the pickling essentially walks the Python AST and understands, oh, this is a function I need to collect, and here's a function that I need to collect, and then serializes this all in a bunch of magic bytes and sends it to the executors. In the Databricks SQL UDFs, we have to be more explicit about the code that we're including. So you really have to make sure that you can't just rely on the system to automatically include functions that are referenced from somewhere else in the code, but you really have to make sure to be relatively verbatim in adding this code to the UDF definition. All right, and then in the last part, you have to bring in your imports. So why is this important? Again, in a very different from the PySpark execution, we don't know what the imports are that you're needing. So you have to basically define your imports in the body of the function definition. Again, this looks a little bit weird, but fundamentally this works as any other Python code. You can run an import statement anywhere. Like you can place it in any line that you want. It's just that your teacher told you at some point in time that imports go to the top, and of course the Google coding style guide. But otherwise, you can just place imports wherever you want and use them. OK, so here I have one example where we're actually having two functions. And say, OK, so I want to register the function redact, which uses this other function that then uses another nested function. How do I do that? All right, very simple. Actually, I just copy and paste the whole code. So I take both functions and I copy them. And since I can define nested functions in any other Python functions, I just basically call my outermost function directly from the source code. So if you see the number 2 here on the bottom, the return my filter, which then calls directly the myFilter function, which then in turn calls the myHash function. So again, this is a little bit work to understand what are my dependencies, what is my code, like how is it composed to then bring it to Databricks SQL functions. OK, so this is really enough of torturing you a little bit with how to really create the right syntax. And I want to walk you through an example of the awesomeness of Databricks SQL and Python UDFs for Databricks SQL. So you've already seen maybe this morning in the keynote how Miranda was presenting how they were using Python UDFs to predict taxi fares. And it stole a little bit our thunder. So I will use this still. We're not using taxi fares here. We're using a slightly different example. But it follows the same footsteps. All right. I come from Berlin. Berlin has gone through a housing crisis, a little bit similar to the Bay Area as well. So rents were increasing dramatically. And people became really creative about, how do I know if I'm not paying too much for my apartment? Well, so there was this one guy, he wrote this nice blog post about how he scraped data from a publicly available source to get a better understanding of if he might pay too much for his rental apartment, or if he's looking for a new apartment if the price was fair. So I said, this is an awesome example of you want to run this in SQL. I want to use this trained model of predicting the price for a rental apartment in SQL, because then I can use this for all my fancy analysts at home, me and my cat, so to say, and then use it. All right. So I'll walk you through the high-level steps of the demo, and then I will run the video for you, and you can see basically that how it's working in the end. OK. So I'm not a data scientist. I'm a hardcore database engine person. So if you see any mistakes in the way that I use scikit-learn, please don't be mad at me. I'm a distributed systems guy. I'm OK at reading scikit-learn tutorials. So please, don't kill me over that. All right. So fundamentally, what I'm doing in the demo is I read a file. I extract the learning data. I'm using a gradient regressor to predict. I extract 2 features. Then, if you see later on the slides, the mean square error is kind of really, really sad. So this just shows that the features are really bad. But it's not about that. It's just I want to show you how everybody can, even me, distributed systems person, can can be, a person that uses ML in their daily life. All right, so I train this regressor, and then I basically generate some SQL code that I can copy and paste into my Databricks SQL editor, and then create the Python UDF. Then, directly from my editor, I actually execute this code, which generates the UDF. And lastly, I simply run a query, and I get results, predicted cost of the apartment. All right. So let's see if this works. All right, I just need to go full screen here. All right, so this is, I have my notebook, I load the file. I now convert this, since I'm using scikit-learn, which means I'm using a Pandas data frame, and I'm extracting the features that I'm looking for, the price of the apartment, which I'm using for training, the living space, and the number of rooms. I'm then loading all the libraries that I need. I extract the necessary columns, convert them to NumPy arrays, and filter out the non-null values. I look at this, OK. I do the train test data split thing to get like 90% of my data is used for the training and then 10% for testing. And here's the part where I'm generating the regressor. The cool thing about scikit-learn is that every regressor that you're building can be pickled. And like I didn't know this before, but then I was like going through the MLflow source code, and I saw like, hey, they're using essentially just like Cloud Pickle on a regressor, storing this on disk. That's awesome for UDFs. So this is where I said, OK, if they can do this on disk, I can do this in base64 encoded text. So OK, so I serialize the regressor, I compress it, I base64 encode it, and then I simply put it into a SQL string. And this is what's happening here. So I basically here have my test data table. I select the number of rooms in the living space. All right. And now the next step, I will simply paste my UDF function in there. And you see the long data string. This is a zip compressed, base64 encoded pickled string of the UDF regressor. And now I'm executing this. This gets registered in Unity catalog. And now I can run my query. And it will now, hello? Ah, no. So yeah, so what I'm doing here is I have to filter out all the null values for number of rooms and living space because my model can't deal with that. I had to learn the hard way. I'm running my query now by applying the Python UDF. So I use the 2 or 3 level namespace syntax for the Unity catalog, so schema, catalog, schema, and table. And now it's executing the UDF. And will give me the results of my predicted apartment prices in about a second. All right. Sorry for that. Yes, it's first-time queries sometimes take a bit longer. But I will talk a bit about like why this is not as fast as it could be. This has to do with basically what Stefania talked about earlier, which is Pandas UDF. All right. OK, cool. So what happened? Let's see. Because when you look at the definition of the template for the UDF that I created, it had this like in this case it's like a 400 kilobyte text string in there, And for every row that we're executing, we have to decompress it, depickle it, base64 decode it. And that's a lot of work that they're doing for 2 float values, So this is where Pandas UDF actually shine a lot because this is row-independent state. That state that I actually want to execute for 1,000 rows at a time, 1,000,000 rows at a time. But we have to start somewhere. So we start with the typical row-wise Python UDFs that we're having, and we're going to focus on giving you the possibility of executing these Pandas UDFs later. All right. So you've seen the awesome demo. You've seen the power of Python UDF. So you can really bring arbitrary code, like all the arbitrary business logic that is important to you, that you use in all your applications, you can bring now to Databricks SQL and use it. Wait, I have, OK. Sorry. OK, so as I said, the most important takeaway is like the power to the SQL people. You have the analysts, you have the people that really want to use the simplicity of SQL in their daily life. But at the same time, there's a lot of business logic that is already existing in Python. You want to bring this over to DBSQL. You want to make sure that the UDFs, the business logic, all of the application logic that you're having follows the same data governance rules that you're using in the rest of the product. And the last part is that all of the transition of your existing logic to Databricks SQL Python UDFs should be as easy as possible and as seamless as possible. All right, so what's the outlook here? So when can we have this? So I would really urge you, please sign up for a private preview. The private preview is running right now. And the public preview for Python UDFs and Databricks SQL is planned for Q3. And now there's a little bit on the roadmap. So obviously, as I said, the most important part is Pandas UDF. Really allowing you to express the code that needs to run as high performance in this way. The other part is user-defined dependencies. Obviously, not all your code fits in 20, 100, 150 lines of Python code. You might have your own repos that you're using, have your own Git repositories, your own PyPy dependencies that you want to use. This is really important to us. And we will focus on this as soon as possible to really allow you to bring your custom code in an easy, reasonable way. The next part is you don't want to necessarily define the Python UDF in Databricks SQL. You want to define it in a notebook and then register it in Unity Catalog. That's a much more convenient way of doing it. However, again, we have to look at this from the perspective of like, how do we phase it and where do we start? And the last part is remote functions. What I mentioned before is that we don't allow network access in the UDFs, which is kind of a departure to how PySpark currently deals with Python UDFs. The reason is, again, for us, it's security and isolation, which is important for Unity Catalog. However, we want to still work with you to understand how would we allow you to do API calls in a UDF. And this is where we want to bring in remote functions, which allow you to basically define a way to interact either with a Lambda function, a Cloud function, or an HTTP endpoint directly from SQL so that you can connect to third-party code that you're having and so on to really even bring in outside connectivity to user-defined functions in Databricks SQL. And with that, I want to thank you a lot for your attention. And if you have any questions, Stefan and me are definitely happy to answer them. Thanks a lot.
Thanks a lot, Martin. Thanks a lot, Stefania. We might have time for 1 or 2 additional questions. So has anyone a question for Stefania or Martin? This one.
So this is all integrated into the Unity catalog, right? Does it also reflect it in the lineage?
Yes, I mean, like my understanding is like every Unity catalog object is reflected in lineage. So yes, all the operations that you're doing on UDFs will be reflected in lineage.
So if you had like a long stream, you could see that on the 3rd stream that it got redacted?
So I'm not sure if 100%.
Like if you have a stream of like 4 or 5 different operations, and on the 2nd operation, it used the UDF to redact the data, like the email.
Yes, I mean, again, in theory.
Would you be able to see that in your lineage?
I mean, that's not implemented yet, so it's very hard for me to say. But again, like, if the UDFs in the same way, SQL UDFs.
Just saying.
No, I mean, I get this, and it makes total sense. It should be registered and used in the same way because they're Unity catalog objects, which then are tracked in lineage. Yeah.
All right.
Hello. For the Python, right, like we install custom libraries. So when we're using the Databricks SQL, so if any custom libraries, how do we import? How do we install there?
Yes. So that's what I had on the roadmap side. This is something where we're trying to, where we're currently working on defining how would you define bringing in your custom libraries. Like, is it just like a PyPy repository? Is it a private PyPy repository? Is it a file that you want to upload to S3 and then reload it? But there are like all these non-functional dependencies. Like you don't want to wait 15 minutes, for all the PyPy packages to install every time you run the UDF. So, we have to put a lot of smarts into making this, efficient. So that's why it's not something that we want to do directly in the first public preview, but really again use the customer feedback to understand what's the way that you package up your dependencies. And this is not just like Python packages, but like Git repositories, all of your own business logic that you might not necessarily package up as regular packages.
Exactly, that's what we're looking like. Yeah, thank you.
And maybe last question from the lady over there.
Thank you. Hi. I have a question. To my understanding, when we active table access level controls on clusters, we cannot write any SQL or Scala on it.
Yes.
So will this have any conflicts?
So actually, that's awesome, this question. I love it. So the benefit is here that if you're using a table access cluster, you can't use UDFs. Well, you can use Python, but you can't use UDFs. And that's why we run these UDFs here sandbox, so that if you're running a DBSQL endpoint, you can actually use Python UDFs. So you get much more than in a traditional table access cluster. You get the power of SQL, you get the power of Python, plus UDFs, And so this is really something, and that's why we're focusing so much on the isolation aspect. So that it's the reason why UDFs are disabled in table access is because the Python is not running as isolated as it could be. And this is really one of the major differences that we're doing here with Databricks SQL and Python UDFs is running them in isolation and fully protected.